we're back. I think the perceived doggy threat is over, although one never knows. So sorry about the barking at the end, towards the end one, the last one. Where was I? I was talking about hurricane names. And I think I mentioned that they come from three languages, French, English, and Spanish. Because we're only really concerning ourselves with Atlantic storms and those in the Gulf of Mexico. Those are the three languages that are spoken in the countries affected by those storms in Central America, Mexico, the United States, and also the islands of the Caribbean. So that's why the names come from those three languages. And if you look at the list of names in the PowerPoint, you'll notice a couple of things. Number one, it is not the complete alphabet. It's not 26 letters. We skip a couple of letters, Y, Z, X, because there are just not that many names that start with those letters to go around. So it's not a complete list of the whole 26 letters in the alphabet. You'll also notice that it starts boy, girl, boy, girl. In 2016, it started with Alex, then Arlene, then Alberto, then Andrea, then Arthur. So the first one this year will be Arthur. Next year, the very first one will be Anna. So not only alternates boy, girl, as you go throughout the years, it also does boy, girl, as you go throughout the list. So it's Arthur for this year, Arthur, Bertha, Cristobal, Dolly, Edward, Faye, Gonzalo, and then you can kind of read the list on down. These lists actually repeat every 6 years. So the list in 2016 is going to be reused in 2022. One exception to that is if a name happens to be retired. Of course, we will retire a hurricane name that will be voted on by the people in the World Meteorological Organization if a storm causes too much death and destruction, because the theory is you don't want to be reminded of that storm. So therefore, that name will be retired and will never be used again, but it will be replaced with a name of the same letter and also of the same sex. So that's why hurricane names are retired. The next slide actually shows, at least up to 2014, some of the retired names. Some of the very famous ones are Hurricane Donna back in 1960. Of course, Camille in 1969 was kind of the gold standard, if you will, of hurricanes as far as destruction until Katrina came along. Camille, of course, hit the Mississippi Gulf Coast and devastated it back in 1969. Some other very famous storms on this list. Hugo in 1989 was a major storm that hit around the Carolinas. Andrew in 1992. That was a storm that went through the state of Florida. It hit around Miami, went over the Florida Peninsula, regrouped in the Caribbean, or regrouped in the Gulf of Mexico, and then came up and hit Louisiana. So it actually had two landfalls. We've had Opal was another big one. Georges in 1998 was a storm that affected Louisiana. And then, of course, you get to 2005. Dennis, Katrina, Rita, Stan, and Wilma. All of those names were retired. That's the most we've ever seen retired in 1 year. And then in 2008 was Gustav. A lot of people will remember Gustav for coming right through the heart of central Louisiana. And since then, we haven't had a lot retired, but there have been a few every year or so. So again, hurricane names, the only storms that have official names, and really it is done to kind of differentiate if you happen to have one or two storms going on at the same time, or at least two or more storms going on at the same time, so you can kind of get a better idea of where those are. So in order for a hurricane to form, much like thunderstorm, you need certain ingredients in order for that thunderstorm to form, or that hurricane to form. First and foremost, as we talked about in the last edition, or at least in the last video, the previous one, we talked about the warm water. That is key. You have to have the warm water. It is kind of, you can think of it as like the gas to the engine of your car. That's why hurricanes fizzle once they get over land, because they no longer have that fuel source. What they're doing is all of that water is getting evaporated up into that storm. So that is really their fuel to keep going. You have to have water of at least 80 degrees Fahrenheit. And that water of 80 degrees Fahrenheit has to be to a depth of 200 feet, from the surface down to about 200 feet. The reason for that is just what I mentioned about a lot of that water gets evaporated up into that storm. So as that top layer of water gets evaporated, it's filled in by the bottom layer. This bottom layer comes up. It's a process called upwelling. But if this bottom layer is too cold when it comes up, it's going to kind of cut off the storm. Doesn't like that gas. It likes warm gas, not cold gas. So that water has to be to a depth of about 200 feet in order for these storms to really develop and then sustain themselves. So ocean water of at least 80 degrees, so very much like bath water. Thing number 2 is you need an area of low pressure. Hurricanes, as we've talked about, are really just areas of low pressure. However, they do not have fronts. Like our low pressure systems that we see on land with a cold front and a warm front, these do not have fronts, but it is an actual center of low pressure. The lower the pressure, the further away from normal pressure, or 29.92 or 1013.25 millibars, the further away you get from that, the lower you get from that, the stronger the storm is going to be. All of a sudden, if a storm gets, one reading is a pressure of one number and then is much lower at the next number, it's what we call a system where it's bombing out, where it's becoming very, very strong, very, very suddenly. So really, you have to have those winds coming in and rising. You've got to have those rising air that, of course, we associate with our low pressure systems. So number 3 is you've got to have air kind of going out from the top. It actually kind of works like a chimney. A chimney takes that air in and then brings it up and then pushes it out at the very top of your house. So it kind of works like a very big chimney. That's kind of the eye of the storm. Winds are coming in at the surface, going up in that low pressure, and then turning outwards at the very top of the atmosphere. The next thing that a storm needs is very humid air in the atmosphere itself. A lot of times if you're watching the news and a hurricane is trying to develop and somebody goes, oh, but you see all of this dry air right there. It's kind of brownish, kind of orangey on television. That could eat away at a storm. So storms really need a lot of humid air. You wouldn't think that's really much of a problem in the Caribbean where these storms develop. But surprisingly, sometimes we can get some very, very dry air, at least in the mid-levels of the atmosphere, and that can eat away at these storms. So it has to be very moist. And then the last thing, very, very light winds at all levels of the atmosphere. If not, hurricanes are round. Got the center in the middle, and then it's round. But if your winds are too strong, they're going to push some of these clouds, and they're going to push them off to the side. So instead of being round, it's going to be more oblong, or all the clouds are going to be on one side of the storm, and no clouds are going to be on the other. When that happens, the storm can't sustain itself. So it has to have very light winds, especially when it's beginning to develop, just so that it doesn't blow all of those thunderstorms. Because really a hurricane is nothing more than a cluster of hundreds of thunderstorms all circling around a common center. So you really have to have very light winds in the upper levels of the atmosphere. So we'll be talking more about development and where these storms develop when we come back next time.